So we learned about geometric sequences a little bit before. We know when it's a geometric sequence if it has what we call actually a common ratio. So common ratio, instead of a common multiple, is the number that you're going to multiply each term by to get the next. Agreed?
Yes.
Okay, another way to get the common ratio is to divide. So I could get the common ratio by going term 2 divided by term 1. 6 divided by 3. That gives me 2, not 3. I can divide. Okay? Or term 3 divided by term 2. That gives me 12 divided by 6, which is also 2. That's another way we can think of the common ratio. Usually I think it's easier just to figure out what are we multiplying by, right? But we need to understand this idea of like the third term divided by the second or the second divided by the first, because there's other applications we might need that. Okay, so the formula for a geometric sequence. Why is it this? Well, let's think of it this way. The first term is just your first term, right? To get to your second term, you have to take your first term and multiply by r. Yeah. This is term 1. This is term 2. This is term 3. Term 4. Okay? To multiply by r. That's why we get t1 times r. To get to your third term, it's like we started our first term, and we multiply it by r how many times? Twice. So t1 times r squared. My fourth term, to get to my fourth term, I would start my first term, and then how many times would I multiply by r? 3 times. T1 times r cubed. So notice that my first term, okay, T1, term 2 is 1, we have 1r. Term 3, we have r squared. Term 4, we have r cubed. It's 1 less than the term number. We're multiplying by r, 1 less than the term number. Okay, so the fifth term would be what? T1 times r to 4. And that's where we get our formula. So T of n equals term 1 times our common ratio to the power of n minus 1. 1 less than the term number. Because that's how many times we're multiplying by the common ratio. Okay? Make sense? Good. So then, how was this question? Terrible. Okay. So, if we want to know how many terms there are, this is a tough question. I will tell you that. Normally, actually, I would put it last, because it is a tough one. Okay, so what do we know about this sequence? Is it geometric? Are we multiplying by the same thing?
Yes.
Yes. It is geometric, and the common ratio is 3. Good. Term 1 is 2. What else do we know? T of n, our last term. Our last term is 14,485. Okay, so we have this formula that I just ran by you very quickly, and we're going to plug in what we know. Okay, so what do we know? T of n, last term. Good. We know our first term. Yeah, 2. Common ratio? 3 to the power of n minus 1. Okay, what I will say is this. Because of BEDMAS, we cannot combine the 2 times 3 because it has this exponent there. Okay? And so what do we have to do? Divide by 2. So we start by dividing by 2. And that gives you 729. Perfect. So here's a problem. The problem is this, is that you're actually going to have a whole unit devoted to solving exponential equations like this in Math 30. Yeah, and you're going to use something called logs. So that log button on your calculator, it's not about chopping wood. It's going to come into play next year. But there is a way we can kind of use guess and check to solve this. And how is that? Well, what we're going to do is the left side of our equation, we're going to make it a 3 to the power of something. So 3 to the power of something equals 729. And this is where the guess and check comes in. Okay, so you're going to grab your calculator, try 3 to the 5, 3 to the 6, 3 to the 7. 3 to the power of something, maybe smaller. 3 to the power of what? 9? 6. Okay, so in your calculator, 3 to the power of 6 equals 729. So I'm going to change 729 to 3 to the power of 6. What does that do for us? It does lots for us, actually. Because now we have this equal to symbol, and so these exponents are equal to each other.
Pardon the interruption. I just wanted to end up providing a little bit of feedback.
So then, well, it's almost as if we can, okay, this is bad math. I'm going to do it. It's almost like we can cross these out, even though we're not really. We're just saying, hey, those are equivalent, so therefore the exponents are equivalent. 6 equals n minus 1. Okay? So we're ignoring the base and we're saying, okay, those are equivalent now. We just have 3 to something equals 3 to something. And so those exponents are equal to, therefore n is equal to 7. Okay. So that was the 7th term. So how many terms are there? There's 7 terms. Okay? Next page. Term 5. Okay. That one's straightforward. Yes? No? Yeah? Okay, because you know n, your subscript there is your n, you know your first term, and you know your common ratio is 3. You're multiplying by 3 each time, so you're just actually plugging it into the formula. Good? Can we move on from that one? Yeah? Okay. This one. I hate this question. We'll do this one last. Okay, this guy. Find the two terms between 3 and 375 if the sequence is geometric. So what do we know? First term is 3. The last term, but it's what do we know what term number that is? So term 4 is 375, and we're looking for the common ratio. If we know the common ratio, we can figure out the rest. Okay, so that means we can sub in our last term, and that's when n is equal to what? 4, right? 375 is term number 4, so that was when n is 4. Okay, so 375 equals 3r cubed. What's our next step? Divide by 3, 175, or 125. And then, opposite of cubing is cubic rooting. And so you should get a common ratio of 5. And if that works out, is that right? Yeah? Yeah. 3 times 5 is 15. 15 times 5? 75. And then 75 times 5? 375. Then we're good. Okay? Are you still with me? Even though we're flying? Yeah? Okay. Let's look at number 5. It's a great question. So the third term, 1, 2, 3. The third term in the sequence is 2. And the 7th term is 512. So 4, 5, 6, 7, 512. Determine the general term of the sequence. So we're going to do something really similar to what we did with the arithmetic. Okay? It's almost like we're going to treat term 2 as our first term. And you actually can do that. And just like remake the sequence and make term 2 your first term. Or you could think of it this way. How many times are we multiplying by r? Did I do enough bumps? 1, 2, 3, yeah. 4? Right? So then, would you agree that our 7th term is equal to my 3rd term times r to the power of 4? Okay, so we're going to get to our 7th term, by taking the third term and multiplying by that common ratio 4 times. Or 512 equals 2 times r to the power of 4. Okay, you with me? No. Yeah, some of you yes, some of you no. Right, so we're doing that same idea that we did with the arithmetic sequence, where we're like, okay, to get to this term, we start at 2 and we multiply by how many times? R by how many times, okay? So we need to get R by itself. First step. Divide by 2, which is 256. And then, now this one you have to be careful for. Oh, I hate this question. Okay, you take the 4th root of both sides. But it's even. So you have to remember something. Okay, grab your calculators. 4th root. Does everyone remember how to do a 4th root? Nope. Okay, this is how you do it. You type 4. You have to actually write in your index. And then you push math 5. Good. So 4th root of 256 is 4. But it's not just 4. It can also be -4. So just like square roots, when you do a square root of both sides, or when you do anything even in even root, you actually have the plus or minus answer. So plus or minus 4 is equal to your common ratio. The reason why is that, I'll show you. So if it was positive 4, if r was positive 4, okay, let's fill in these blanks. So multiplying 2 by 4, 8 times 4, 32, times 4, 128. Okay. And then the other direction, if I'm dividing by 4, this gives me a half and an eighth. Okay, so that would work. What does it say? Determine the general term for the sequence. Okay, we just need to get the formula. But I'm just going to show you that it could be both. The reason why it could also be -4, okay, so if we do the same idea here, 1, 2, 2, 1, 2, 3, 5, 12, whenever there's an odd space in between, I can multiply by -4. So if I multiply by -4, 2 times -4 is -8, then times that by -4, positive 32, times that by -4, -128. And then it still gives us that positive 512. Going backwards, divide by -4, -0.5, and then divide by -4, positive an 8. Okay, so when you take the 4th root, that's really important. Whenever it's a square root, 4th root, 6th root, you have plus or minus as your solution. So then our general term then for this would be t of n equals, we have 2 options. The first one would be, you need your first term, which was 1/8. We figured that out. Times my common ratio, 4 to the power of n minus 1. Or the other answer would be 1/8 -4 to the power of n minus 1. Do you agree that that was the first term? Did I do that right? I was moving really fast. Yeah? We're good? So there's 2 answers for this problem. So you would have to find both. Most likely, you'll probably have a problem. That's where it's like a cube root, so you won't have that issue of having the even index. But it does show up on your homework, and so it is fair game. Yeah, so you'd have to give both. Okay. All right, let's look at number 6 is just like we looked at a problem like that. Let's look at number 7. Okay, a ball is dropped from a height of 15 meters. Did you do the ball question? No. Okay. Star this. It's very important. Okay, so when you draw these out, you're going to want to draw out every single bounce. And what I recommend is don't draw it like this. It's too tight. We're going to over-exaggerate everything. So this question says a ball is dropped from a height of 15 meters. After each bounce, it reaches 3/4 of the previous height. Determine how high the ball will reach after the 7th bounce. Okay? So after the 7th bounce, that's very confusing. So we're going to draw it to see what they mean. So it starts here, and it falls, right? Now I'm going to really spread this out. So instead of drawing it like straight up and down, I need to spread it out. Here's my first bounce, and it fell 15 meters first, right? And then it goes 3/4 its previous height. So how high is that? 12 point something? 75? Yeah, that's right. 11.25? Up 11.25 and then down 11.25, right? It's a bouncing ball. If it goes up, it must come down the same height. Okay, so let's do this all the way, and it says after the 7th bounce. So we're going to draw at least 7 bounces, and then we'll talk about if we need to draw more. Bounce 3. Don't worry if it doesn't look like 3/4 the previous height. Just really over-exaggerate this. Bounce 5, 6, and 7. Okay, now we want to know how high the ball will reach after the 7th height, a bounce. So that's like over here. We want to know this height. This is at my unknown. Okay. Now there's 2 options on how you set this up. The first is, and how we set it up differently is where we make our first term. Okay. Now we want to find this height here after the 7th bounce. That's what we're looking for. So what I'm going to do is I'm going to take all of these guys, and those are my terms. Those heights are going to be my terms. Okay? So if I do that, that means I'm going to make term 1 11.25. This will be term 2, term 3, 4, 5, 6. So we're looking for term 7. And that's if we make 11.25 our first term, because that's the one I'm looking for after the 7th bounce. Right? So this is the height it goes up after it bounces the 7th time. And that's what we're looking for. Okay. So I will show you another way to solve this using 15 as your first term, but just hold tight, okay? So the first way to solve this is, so we're going to make term 1 11.25. And because we're looking for term 7, that means n is equal to 7. Common ratio is 3/4, because it's 3/4 the previous height. Okay, so let's find T7. So T7, now we got our first term, 11.25. So we're using the formula T1 times R to the power of n minus 1. Common ratio is 3/4. Sorry. I hate that. 3/4 to the power of 7 minus 1. When you plug this into your calculator, if your calculator is not updated, your exponent needs to be in brackets. So it depends on your calculator. I would also put 3/4. You have to put 3/4 in brackets. Okay, to the power of 7 minus 1, you might just want to write 6, and then you're safe. My calculator is nice to me because it's updated, because it's on the computer. Oh, it's on the other screen. LCD, where are you? There it is. Okay. If yours doesn't, if it like just says the hat and you see that actual hat, and by hat I mean this symbol right here, then you have to put 7 minus 1 in brackets, or else you won't get the same answer. Or just write 6. So you should get 2.00. Yeah? You got 2.00? Good. Okay. Good? Okay, if not, we need to figure out what's wrong with your calculator. Well, what's wrong with being typed. Okay? So 2.00. That's your height after the 7th bounce. There's our answer. Now the other way we could set this same problem up is if, so this was 15. Do I want to draw this all over again? Not really. Okay, so if we treat, I'm going to use a highlighter again. If I want to make this my term 1, okay, so if I want to make 15 my term 1, then what I'm looking for, this would be term 2, 3, 4, 5, 6, 7. We need to find term 8. So after the 7th bounce, when it goes up, it also goes down the same. So we'd be looking for term 8 if we're using term 1 equals 15. Okay, so you could use 15 as your first term, but then your n value is going to be 8, and that would also give you 2.00 as your answer. Okay, I don't know, so your call. Okay, we better go back to that one question with the variables, and then we can move on to the next lesson. So let's go back. Daily quiz? Debating if we have time. We have a quiz tomorrow, yeah, that's why. So, yeah. Okay, let's see how we're going to do. Let's just see what we can get through, and then we'll go from there. Okay, find an integer x. So x plus 1, x plus 7, and 2x plus 4 are terms in a geometric sequence. Okay, remember the questions with the arithmetic? How do we relate the arithmetic ones? Remember what we did? If it was arithmetic, how did we relate them? Our terms, our 3 terms. Yeah?
It was the difference is equal to the second minus the first is equal to the third minus the second.
Perfect. So what we did is we used a common difference. And we did second term minus first equals third minus second. So we're going to use the same sort of strategy. Okay, but the strategy here is that it's geometric, so we're going to relate their common ratios. Okay, so what are the 2 common ratios? Common ratio can be, instead of second minus first, it's second divide. Because we're multiplying, so to get the common ratio, we divide. So the other one would be third. Common ratio could also be the third term divided by the second. And so we're going to relate those together. So in this case, term 2 is x plus 7 divided by x plus 1 equals, bless you, add 2x plus 4 divided by x plus 7. Okay. Agreed? So we're relating the common ratios. So that's what we're doing. Is relating the common ratios. Those are equivalent. Okay, this is a fun one. What I could say is, let's factor this right side over here. Can you factor that numerator? What can we do? Is there something we can factor out? So here, everything stays the same except for this one here. What can you factor out of those 2 numbers? GCF. It's just GCF. What can you divide both those numbers by? 2. Okay, so what we're going to do is we're going to actually factor out 2. So if I pull out a 2, do you remember that? Sort of. This is a tough question. Okay, so that gives me, if I factor the 2, what's left over inside? X plus 7. Yay! What happens with our x plus 7s? They can actually cancel out. Okay, so now this is a lot easier. Now we have x plus 7 over x plus 1 equals 2, or 2 over 1, if you want to write it as a fraction. Where can I go with this? Cross multiply. Great. So x plus 7 equals 2 times x plus 1. So let's solve for x. 2x plus 2. And this is x plus 7. So get our x's all to one side. So really quickly, I'm going to subtract x and bring the x to the right side. And I'm going to bring 2 to the left side. So subtract 2. And I get 5 equals x. That's my answer. Okay. So, in a nutshell, do you feel a little bit more comfortable with this stuff?
Better.
Yes? No? Some of you know. You're going to need to do some homework tonight and practice. I'm not sure if you attempted it this weekend. Hopefully this makes a lot more sense. I'm really hoping that. Okay, I'm going to stop